Hello everyone, July 25th. Alright, I want to do a fast one today because my brain is tired. So I probably don't have enough brain power to do this. Alright, let's get this one done and then call it a day. Array as a mountain, if the following property holds, larger than 3, exists some I such that goes up and goes down. Given a mountain array, return the index such that this. So you want to return all the peaks. You must solve it in O, log, and time complexity. Ooh. So we have this. Right, and we don't want to find the indices of these things. And of course, ON can work. ON will always work. You just go up, and then once you go down, and that's oh wait, hold a second. It has to be a peak. Wait. Exists I such that this and this. Oh, my bad. It's not this. Ugh. I think it's easier. It's not. I only have one peak. I only have one peak. So you want to find the peak. Find this one peak. Oh, I think I remember this. Binary search, right? Binary search. Oh, how do we do this binary search? Well, I mean, you pick a mid, right? And then you see, oh yeah, you see the two values on both sides. If we're in the upper trend, then we should go on one side. If we're on the lower trend, we should go there, and blah, 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 blah. Eventually we'll end up with the middle. Something like that. Something like that. All right, let's binary search this baby. Let's binary search this baby. You know what? If we can solve it like this in one shot, maybe I have some kind to give the other problem a look again. All right, so binary search, low, high, 0, and len array. Okay. Then what? Then while low smaller than high, mid is 2, right? And then you need to say it exists, so I don't have to check. Middle becomes 0, so no, it's fine. So what I need to check is if array low mid -1, right? If array this is smaller than array mid, smaller than array mid +1, that means we're on the left hand side, so we need to move to the right. So low shall equal to mid +1. Elif this is larger than this, larger than this. Okay. Then high shall equal to mid. Else. Else. Well, the else then we can just return mid. Otherwise we'll return. Yeah, I don't think we can return it because it always exists, right? If it always exists, then we can just return here. Let's give this a shot. 0, 2, 1, 0, 10, 10, 5, 2. Peak. Looks like it's gonna be right. Old problem. Oh my, 2019. That was a long time ago. That was a long time ago. 32 test. Madre mia. Oh, this is binary search. Oh yeah, this is enough. This is enough. That is true. This is enough. How many test cases do we have this time? 42. Binary search. Uh, 852. Yeah, I think we can make it a little nicer. Yeah, that's true. This is the only thing we need to compare. If this straight, that means you're on the left hand side. Else then high or equal to low. The high or equal to mid. Right? If this, you're always on the left hand side, we try to push on the right. And also if no if, all right? And otherwise, if it's array mid is larger than, then we do this. And eventually, I think eventually, when we get out, because low, I move to, so mid is this, and then low we move this. So yeah, eventually should return low. Yeah, this is nicer. Yep. Solution, linear scan, binary search. Yep. Okay. We're doing it pretty fast. Maybe we do want to try this one more time. Okay, let's just try this maybe 10 minutes. All right, I'm gonna use the same idea as yesterday. So again, I think I will do 0, 1, 2, 3, 4. Okay, I get a little bit more. So size 2. Okay, so 0 with size 2. I have 0, 1, 0, 2, 0, 3, 0, 4. Right? 0 is size 3. We have 0, 1, 2, 0, 1, 3, 0, 1, 4, 0, 2, 3, 0, 2, 4, 0, 3, 4. Right? 0 and 3. That's it. That's all this. And then 0 is 4. 0, 1, 2, 3. 0, 1, 2, 4. And 0, 1, 3, 4. Right? And then 0, 1, 4. Nothing. So 0, 2, 3, 4. Right? And then 0, 2, 3. And then 0, 3. No 0, 3. Okay, that's that. And then also 0 and 5. 0, 1, 2, 3, 4. So these are all the possible, right? So for each one of them, what is the value? That's going to be 0 times 1 squared, right? Plus 0, plus 0, 1 squared, 2 squared, plus 4 squared. This is going to be 0, 2 squared, 3 squared, 4 squared. 0, 3 squared, 4 squared. 0, 4 squared. This is going to be 0, 2 squared, no, 3 squared plus 4 squared. 0, 4 squared. 0, 4 squared. Damn! And this is 0, 4 squared. Whoa! That is, I think it's different from what I had yesterday. So this is all the zeros. Right? This is all the zeros. Yeah, we have 1, 2, 3, 4, 2, 3, 4, 3, 4. That's good, and 4. Second level, 3, 4, and 4. And third level, we have 4, and we have a 4 again. Damn. Yep, that's why it's complicated. Yeah, so it's hard. It'll be hard to rationalize, right? Maybe that's not a way to think about this problem. Maybe what we should think about the problem is, if I start, how about this? If I start from, if the mean is 0, okay, mean is 0, max is 1, we have 1, right? We have one possibility. If I mean is, hold on, if mean is 0, max is 2, okay, then how many are there in this range? Well, with 0, 1, 2, we have 3 values, right? We have 3 values, but we have to include 0 and 2, right? So this is one possibility. So number of possibilities, this is just 1, 0, 1. This we have 0, 2, we have 0, 1, 2, right? So they have 2. This will have 2 possibilities, right? I have 2 possibilities. 0 and 3. Well, 0 and 3, in between we have 1, 2, we have 2 values, right? We have 0, 1, 2, 3, we have 2 values, plus a empty. So basically, this shall have 3. 2 to the 2 to the, because we have to choose, right? So this is basically we have an empty. So C, so 3 choose 1, 0, 3, 0, 1, and 0, 2, plus, you know what? I think it should just be C, 2 choose 1 plus 2 choose 2, and plus 1, which is the empty set. And in this case, so that will be 2 choose 0, right? And that should be 2 to the 2. We have 1, 2, 1, 2, and empty. So that's 4, right? So if we do 0, 4, we have 3 in between, so there are 2 to the 3rd, so it should be 8. Right, we have 1, 2, 3, 4, 5, 6, 7, 8. All right. So if we have 1 and 2, that's because it's nothing, right? So that's 1. And 1, 3, that's 2. 1, 4, That's 4. And we have 2, 3, 2, 4. 2, 3 shall be 1. 2, 4 shall be 2. So the answer for this one shall be 0 times 1 squared times 1, right? Plus 0 times 2 squared times 2 plus 0 times 3 squared times 4. Yeah, let's not use 0. Yeah, let's not use 0. That's just too special. So we're gonna go 1. Yeah, let me redo this. Let me redo this. Results shall be similar. So if 1, 1, 1, 1, 1, 2, 3, 4, 5. 2, 2, 2, 3, 4, 5. 3, 3, 4, 5, right? So it'll be 1 times, no. Hold on, let me redo this. I feel we are at the right path. So it'll be 1 times 2 squared times 1 plus 1 times 3 squared times 2 plus 1 times 4 squared times 4 plus 1 times 5 squared times 8. And then 2 times 3 squared times 1. 2 times 4 squared times 2. 2 times 5 squared times 4. 3 times 4 squared times 1. 3 times 5 squared times 2. Okay? And plus, I mean, you can even say 1 on 1, right? 1 on 1, that will just be 1 times 1 squared times, because it's 0, and 2 to the, yeah, you can't really do that. Yeah, you cannot really do that. Yeah, let's ignore this. And then, of course, plus 1, 2, 3, 4, and 5. Let's see if this is correct. Is there any faster way to do this? Except from, you know, just brute force it. I mean, we can brute force it. It's not too bad. It's not too bad. Hold on. It will be bad because, well, hold on. Let's calculate this one first. I mean, how am I supposed to calculate this faster? I don't have my calculator. It's alright, let's just write it out. So that's 4 plus 18 plus 64 plus 200. What's this? 18. Oh dear Lord. 4 to the third, that's 64 again. 25. Huh? That's the same. That's also 200. 46, 48. 25, 50, 150. Okay, that's 1, 8, 27, 64, and 125. Alright, let's add these together and just see if it's correct. Where's my calculator? Alright, so 4 plus 18 plus 64 plus 200 plus 18 plus 64 plus 200 plus 48 plus 150 plus 1 plus 8 plus 27 plus 64 plus 125. I got 991. 991. Let's try this. 1, 2, 3, 4, 5. 991. Nope. I'm 100 short. Damn it. Gosh, man. 100 short. It could be the calculation, it could be many things, right? It could be many things. Hold on. Let's see one more time. It's minimum maximum squared times minimum. Yeah, so that is correct. That is correct. So we need to find out why. Well, I mean, let's use an easier case. I mean, this is definitely not an easy case. Easy case. 1, 2, 4. How about that? So, right. So we can say 1 and 2. Right. 1 and 2. That's we have 1. 1 and 4. We have 2. Okay. This is the mean. This is max. This is count. And we do 1, 2, 1, 4. All right, start with 2. We have 2, 4. That's 1. That's it. So we have 1 times 2 squared times 1 plus 1 times 4 squared times 2 plus 2 times 4 squared times 1 plus 1 triple, 2 triple, and 4 triple. So this is 4, 32. This is 32 again. 1, 8, and 64. All right, let's calculate it. Is it right? 4 plus 32 plus 32 plus 1 plus 8 plus 64. 141. That is correct. So why the hell the other one is not right? Oh, you asking me? Oh, I know why. Because I forgot a 4, 5. Damn, 4, 5 has 1. So we forgot 4 times 5 squared times 1. Yes, that's 100. All right, let's have another 100. All right, I think I solved this problem. No, we find a way, but the number length is 10 to the 5th. All right, if you do this, it's O(n) squared. Right, you have to calculate the full thing and a full thing and a full thing. So we have to make it faster to calculate this thing. How do we make it faster to calculate this? Let's get a new page. We need to make it faster, right? So we can say V0, V1, V2, V3, V4, okay? So what we do is V0 times V1 squared plus V0 times V2 squared times 2 to the 1 plus V0 times V3 squared times 2 to the 2 plus V0 times V4 squared 2 to the 3. So we will let's plus tell us V0 VK squared. Let's use Vn. Okay, Vn squared times 2 to the what? 2 to the n minus 1, right? Because that's 2, 2 minus 1, 3 minus 1, 4 minus 1. Okay, that's the first, right? That's 1. And then we have to do V1, V2 squared, V1, V3 squared, 2 to the 1. Right? V1, V4 squared, 2 to the 2. V1, Vn squared, 2 to the what? N minus 2. N minus 2, right? N minus 2. And then we have V2, V3 squared. We can say V2, Vn, 2 to the n minus 3. All the way down, we have V, last one, n minus 1, Vn squared. And 2 to the n minus that's a squared. n minus 3, right? Why is 3? Basically, it's n minus this minus 1. So 2 to the n minus n minus 1 minus 1. N minus n plus 1. Yeah, that's 0. That is correct. Okay, so how do we simplify this computation? I have no clue. Honestly, I have no clue. I don't know, honestly. But we did you see anything that's interesting that can can be used? I mean, for one thing, we can put like we'll take v0 out. That's v1 squared and 2v2 squared. 2 to the n minus 1 vn squared, and then v1 out. It's v2 squared plus 2v3 squared plus 2 to the n minus 2 vn squared. All right, and then we can say v2 is v3 squared, 2v4 squared, 2 to the n minus 3 vn squared, vn minus 1 times vn squared. Okay, so that's the whole thing. How would you summarize this? Or if I have v1 squared plus v2 squared plus 2vn squared, if I have that, I also have v2 squared but I need to multiply by 2, to multiply by 4. So you multiplied okay, so let's say vn squared, right? And then vn squared you multiply by 2. Ooh, hold on. That might be like, if I have this, if I have v3 squared plus 2v4 squared plus plus 2 to the n minus 3 vn squared, I multiplied by 2, I'll get the remaining. So all I need to do is just plus a v2 squared. Ah, I see. Now I see. Now I see. So what I do is I start from vn squared. We start from vn squared, and we calculated, vn minus 1 times this, whatever. And then we will 2 times vn squared plus vn minus 1 squared. And then we do vn minus 2. I think this one has more promise. This one definitely has more promise. We got mod, we got this. We don't do any of that. What we do is we pick the last one. So pre shall equal to 0. Okay. Pre equal to res equal to 0. And for I in range minus 1, not len, nums minus 1, minus 1, minus 1. Actually, we have to consider how much do we go, because we're starting from this, right? So we don't go all the way, like we are here, and then we will add this. So actually, I'm gonna say all the way to 0. Okay. Then we say current shall equal to 2 times pre, okay, plus nums I squared, right? 2 times the pre plus the current one squared. Once we do that, res equal to res plus, we'll probably need a mod here as well, because it's all plus and mod, it's fine. Res plus current times nums I minus 1. Right, so initially is this with times I minus 1, and we'll mod. Once we're done, pre equal to current. Then we go again. Now it's 2 times this, right? Because we start from the last one. So the next one we're pointing to this. So 2 times this plus this squared, and multiply by this. And then we go all the way down, and then we return res. Try it. Oh my god. That ain't right. That ain't right, man. I don't know. That's okay. Num.sort, and we can take a look at bonkers. Just bonkers. Hold on. 1, 2, 4. Okay, 1, 2, 4. So we'll do 2 times 4 squared, right? And then we have 2 times 4 squared, and then we'll times and 2 plus this, 2 squared plus this, and this times 1. Oh yeah, I remember. I know why, because I forgot to, sorry. So pre is this, res shall equal to sum n to the third for any nums, and this shall be right. Yep. Singles. Team, is it team, right? That's the thing, is team. Heroes, yeah. Group of length 1. Group of length 1. Yeah, this is right. I am very, very sure this is right. Test case. So I use this test case. Wait, is this? That's not a test case. Come on. That's not a test case. Test case is this. This is the test case. Yeah, we can. In fact, we can use this as a test case. Hold on. This is actually we can use this as a test case. We just need to delete the 10. Give it a shot. How's this one go? Yep, we got it. So we just need to, I'll write it. Sort nums, right? And then for each pair of min max, right? Each pair of min max, we can find the total number of groups, right, that can form with min and max being can form including min and max, right? Including min and max. For instance, given v0, v1, v2, v3, v4, right? v0, v1 have one group. v0, v2 has 2 to the 1 equal to 2 groups. Right, 2 to the 0. So this is actually 0 choose 0, right? And this is 1 choose 0 plus 1 choose 1. Okay. V3 shall be 2 choose 0 plus 2 choose 1 plus 2 choose 2 equals 2 to the 2. And this is 3 or 4. It's going to be 3 choose 0, 3 choose 1, 3 choose 3, 3 choose 2, 3 choose 3 equals 2 to the third groups. Thus, starting from V0, we have the total score V0 times V1 squared. Wait, hold on, I need to pull this out. V0 times V1 squared plus 2 times V2 squared plus 4 times V3 squared, right? Plus 8 times V4 squared. Yeah, might as well just 2 to the 1, 2 to the 0, 2 to the 1, 2 to the 2, and the 2 to the 3. Alright. Similarly, starting from V1, we have the total score V1 times 2, this will be 2, 3, 4. Okay. Starting from V1, V2, and V3, we have the total score this and this. So V2, we start with V3, and then we have V4. That's it. And V3, we just have V4. That's it. Right? Thus, to compute their sums fast, we start from V4 squared. Right? We start from V4 squared. We start from V3 times V4 squared. Then double V4 squared. Then double V4 squared and add V3 squared. We start from then we do V3 squared times V4 squared times 2, right? We can do the following. Plus, and then V2 times, right? And then V1 times v2 squared plus this times 2. Okay, and then v0 times this whole thing, v1 squared plus times 2. And eventually, and finally, do not forget to include all the groups with a single member whose score is the triplo. The third power was a square, no, square cube of each value. ON. All right, proudly submit this. You gotta be kidding me. You gotta be kidding me, man. You gotta be kidding me. You gotta be kidding me. Python, pow. I'd say mod. You gotta be kidding me, man. And all of this have to make sure. Oh, sorry, I forgot another one. All right, that was an oversight. Let's go. That is the one. Yeah, tricky. Very tricky test case. Good question. We solved it on our own. Okay, that will be it, I think. Yeah. That'll be it. Maybe I can post mine, you know? That's fine. I think they all have good explanation. You know what? I'll just post yours for fun. Just, I think, but it's the same. All right, it's the same. All I want to do is just show this thing. Yeah, you don't have to show this thing. That's okay. All right, move on.